Hey guys, so in this video we're going to learn about restricted domains. Now what do we mean by a restricted domain? Let's look at an example of a function f of x is equal to 1 divided by x minus 2. So here I have my function, and the question that I have over here is what is the domain for this function? Now if you remember, the domain of a function is the set of inputs accepted by a function. Now over here, right, the input x cannot be equal to 2. The reason why is because x minus 2 is in the denominator, and the denominator can't be equal to 0 because then we'd have 1 divided by 0, and we know that anything divided by 0 would be undefined. We can't really divide anything by 0. So here the denominator x minus 2 cannot be equal to 0. So we know that this denominator x minus 2 is equal to 0 when x is equal to 2. So for the domain, x cannot be equal to 2, right? The input cannot be equal to 2 since 2 is not going to be an acceptable input for this function. So we can say that the domain over here, which is a set of inputs accepted by a function, right? The input here being x, is that x is a real number, but x cannot be equal to 2. So x is not equal to 2, and obviously any other real number is an acceptable input over here. So we can say that x belongs to the set of real numbers. However, x is equal to 2 is not an acceptable input. Therefore, x is not equal to 2. Or more simply, we can say that the domain over here is x is not equal to 2. This is just a simplified way of stating it. This implies that x is a real number. However, x cannot be equal to 2. So we can say over here that this function is defined for all real values of x except x is equal to 2. In other words, the input over here can be any real number except 2. Now the next question that I have over here is, what is the range of this function? Now we know that the range is a set of outputs given by a function. So over here, let's say that we have y is equal to f of x. So if x is the input over here, then the output is given as y. And let's look at a graph of y is equal to f of x. In other words, let's look at the graph of y is equal to 1 over x minus 2. So here we have the graph for y is equal to 1 divided by x minus 2. And the first thing that we notice over here is that when x is equal to 2, the function is undefined. Right? Because when x is equal to 2, we'll be doing 1 divided by 0, and we can't divide by 0. So when x is equal to 2, the function is undefined. Right? There's no output there. But now let's look at what happens when x increases. In other words, when x is greater than 2. And when x is slightly greater than 2, so for example, if x was something like 2.0001, right, then you would be doing 1 divided by 0.0001. In other words, right, if x is only slightly greater than 2, the output y would be very large, right? If you were doing 1 divided by a very small number here, very small positive number, you'd get a very large positive value for y. And now as x increases, right, y gets smaller and smaller because as x increases, you're dividing by a much larger number, and therefore y is getting closer and closer to 0 as you move to the right. However, y is never actually equal to 0. There's no value of x that gives us a value of y equal to 0. It gets closer and closer to 0 as we move to the right, but it never equals 0, since 1 divided by something can never give us 0. Similarly, if we go to the left of x is equal to 2, what we see is if x is only slightly smaller than 2, right? So for example, it's something like 1.9999, right? Then what we're doing is we're dividing 1 by negative 0.0001. So we're going to get a very large negative value. Right? And as x becomes more and more negative, what we see is we're doing 1 divided by a very large negative number. So again, the value remains negative, but it gets less negative. It gets closer and closer to 0. But again, it never equals 0. Y never equals 0 because 1 divided by something will never give us 0. So it gets closer and closer to 0. So when we talk about the range of this function, that's the set of outputs given by this function. In other words, a set of values for y, or f of x over here. Right? As we move from left to right, we know that y is never going to be equal to 0, right? But it will get very, very close to 0. And as you move from left to right, what we see is as we approach x is equal to 2, right? As x gets closer and closer to 2 from the left-hand side, y is infinitely negative, right? It gets infinitely negative. It never actually It doesn't have a value at x is equal to 2, but we can get very, very, very close to 2, and we'll get a very, very large negative value, an infinitely large negative value over here. Similarly, at x is equal to 2, we know that's undefined, and when we go past x is equal to 2, right, we have a very, very large, infinitely large value over here, right, positive value. And then again, y gets closer and closer to 0, but it never actually equals 0. So over here we can see that depending on the input, y can be any negative real number and it can be any positive real number, but it'll never be equal to 0. So when we talk about the range for this function, we can say that the range of f of x, right, f of x can be any real number, but f of x cannot be equal to 0. So we can say f of x is such that f of x is not equal to 0. However, it can be any other real number. So in other words, the range over here is the set of real numbers except 0. Okay. Similarly, since y is equal to f of x, we can say that the range over here is the possible values of y given by this function, right? That's the set of outputs. And we can say over here that y is not equal to 0. However, y can be any other real number. So we can say again that the range is the set of all real numbers excluding 0. And this can be written in a simplified form as that f of x is not equal to 0, or we can say that y is not equal to 0. Over here again, it's implied that f of x or y, the output, can be any real number. However, it cannot be equal to 0. So the domain over here is that x can be any real number except 2. X cannot be equal to 2. And the range over here, f of x or y, can be any real number. The output can be any real number except 0. We cannot get 0 as an output over here. Now the next question that I have over here is this a one-to-one function? And we can determine that again using the horizontal line test. So here I've drawn the horizontal line on the graph for y is equal to f of x, right? And what we see over here is that this horizontal line, right? We can draw this horizontal line anywhere. And what we see is that this horizontal line intersects the curve at most once, at no more than one point. Obviously, this horizontal line represents the output y. Now we know that y is equal to 0 is not a possible output. So there are no inputs that will give us the output y is equal to 0. However, what we also see is that for any of the other outputs, so again, the horizontal line represents the output, we see that this intersects the curve only once, right? Or at most once. For any given output, that means that any given output, right, is going to be given by a different input. In other words, no two different inputs give us the same output over here. So therefore, we can say over here that this is a one-to-one function.
Quick pause. If you're finding value in this explanation, there's so much more to discover. At Alt Academy, we break down every A-level concept with the same level of clarity. Now, let's continue.
One final thing to note over here is that for this type of a function where the input is in the denominator, you should know that the denominator cannot be equal to 0. So the domain over here was restricted by the fact that we can't have 1 divided by 0. We can't have something divided by 0. So over here, x couldn't be equal to 2. So that was the restriction on the domain. Whenever we're dividing by something, right, and the input is in the denominator over here, we know that we can't have any value for the input which would give us the denominator to be equal to 0. So now let's look at the next example. Let's say I have a function, okay, and here I'm going to use the letter g to represent the function, okay, and I have g of x is equal to the square root of x minus 1. Now what is the domain for this function? Again, the domain is the set of inputs accepted by a function. So we want to know what are the possible values of x that this function will accept. Now over here, since we're taking the square root of x minus 1, we know that we can't take the square root of a negative number. We can't take the square root of a negative number. So we know that x minus 1 has to be greater than or equal to 0. In other words, x has to be greater than or equal to 1, right? If x was less than 1, then we'd have a negative number over here, and we can't take the square root of a negative number. So over here, what we can say is that the domain over here is the input x is such that x is greater than or equal to 1, and obviously x is a real number. So we can say over here that the domain over here is the set of all real numbers that are greater than or equal to 1. And this can be written in a simpler form as simply as x is greater than or equal to 1. So we can say that this function here is defined for all real values of x that are greater than or equal to 1. Now what is the range of this function? You know, the range is the set of outputs given by a function. So over here, let's say that y is equal to g of x. Let's say over here that y is equal to g of x. And let's look at the graph for y is equal to g of x. In other words, let's look at the graph for y is equal to the square root of x minus 1. So here's the graph for y is equal to the square root of x minus 1. And what we can see over here is obviously that x can't be less than 1 over here, since then we would have the square root of a negative number. So the smallest possible value of x that we have over here is x is equal to 1. And at that point, the output y is equal to the square root of 1 minus 1. So that's the square root of 0. So the lowest possible value for the output is 0, right? And as x increases, y also increases. So over here, what we can say is that the range of this function is g of x such that g of x is always greater than or equal to 0. And obviously g of x is a real number. So we can say over here that the range is the set of all real numbers that are greater than or equal to 0. And since y is equal to g of x, we can say that over here the range is y is such that y is greater than or equal to 0. And y obviously belongs to the set of real numbers. And this can be written more simply as the range is g of x is greater than or equal to 0, or we can say that y is greater than or equal to 0. This here again implies that the output g of x, or the output y, is a real number that is greater than or equal to 0. So again, the domain over here is the set of all real numbers that are greater than or equal to 1, and the range over here is the set of all real numbers that are greater than or equal to 0. So over here, because we were taking the square root of something, right, and the input was underneath that square root over here, we know that whatever we're taking the square root of has to be greater than or equal to 0. So the domain over here was restricted by the fact that x minus 1 has to be greater than or equal to 0. Therefore, x has to be greater than or equal to 1. So that gives us our restricted domain here. Now let's look at the next example that we have. Let's say I have a function h of x is equal to x minus 2, the whole thing squared. Now, the domain of this function, the natural domain of this function, is the set of real numbers. We know that if we take any real number as the input over here, we will get an output, right? So x could be any real number as the input over here, and we would get an output. However, when defining this function, I can also choose to restrict the domain. So I can say over here that h of x is equal to x minus 2 the whole thing squared only if x is greater than or equal to 2, for example. So in the previous cases, what we saw was in the first case, we had f of x is equal to 1 divided by x minus 2. And here the natural domain was that x could not be equal to 2 because we can't divide by 0 over here, right? So that was the set of inputs accepted by this function was all the real numbers except 2. Similarly, in the next example, what we saw was that when g of x was equal to the square root of x minus 1, x had to be greater than or equal to 1. That was the natural domain over here because we can't take the square root of a negative number. So our domain over here was the set of real numbers that are greater than or equal to 1. Now in this particular case, the natural domain is a set of real numbers. However, we can also choose to define a function with a restricted domain. So in this particular case, the natural domain would be the set of real numbers. However, I've chosen to define the function h of x as x minus 2 the whole thing squared only if x is greater than or equal to 2. So here I've chosen to restrict the domain. Now what is the range for this function? Well, let's say over here that y is equal to f of x. So let's look at the graph for y is equal to f of x. That is the graph of y is equal to x minus 2 the whole thing squared when x is greater than or equal to 2. So this is what the graph looks like over here, right? Now if we simply had y is equal to x minus 2 the whole thing squared and x wasn't restricted, we'd have a parabola. But in this case, because we've said that x has to be greater than or equal to 2, we're going to start at x is equal to 2 and then we're going to move to the right. Now the minimum value over here of y is equal to 0. So when x is equal to 2, y is equal to 0. And then as x increases, we can see that y also increases. As we move to the right, y increases. So over here we can say that the range for this function, right, is f of x such that f of x is always greater than or equal to 0. And obviously f of x is a real number. Or we can say over here that the range is, since y is equal to f of x, we can say that the range of y over here is such that y is greater than or equal to 0. And obviously again y is a real number. Or in simpler terms, we can say that the range over here is f of x is greater than or equal to 0. Again, it's implied over here that f of x is a real number. Or we can say that y is greater than or equal to 0.
Now that that's taken care of, head over to our website to watch the rest of our A-Levels maths course. With 60,000 students trusting us, visit All Academy now and transform your A-Levels journey.